nanoHUB.org.
Online simulation and more for nanotechnology.
I'd like to first of all thank a bunch of folks at MathWorks for letting us deploy MATLAB for free in nanoHUB for our users. So we're very, very thankful for them. And specifically, I'd like to thank Gen for working very hard in preparing this talk that I know it's going to be very interesting to all of you. So with that said, so Gen has a bachelor's and a master's degree with a focus on control systems. He worked on automotive applications for nearly 30 years. Lots of control systems embedded in automobiles. So he has a lot of experience, and he's currently a customer success engineer at MathWorks. And his job is to work with academicians, with university professors and students to make sure we get the most out of the MathWorks products. And this is exactly what we're doing today with Gen. So he's going to tell us how we can all use MATLAB for data analysis. If you're a professor, you can use this in your classroom. The tool is open in nanoHUB. There are many other ways. You can contact Gen to access MATLAB. But as you all know, it's a super powerful tool, and we're more than excited to welcome Gen to our workshop series. And with that, take it away, Gen.
Okay. Thank you, Ali. And thank you, Aaron, for hosting us. Again, my name is Gen Sasaki. I'm a customer success engineer. And today, I'd like to present to you all just simply, data analysis with MATLAB. And now that you have MATLAB available through nanoHUB, hopefully you'll have a chance to take advantage of its power and usability. This is only an introduction, but if you don't know MATLAB, don't worry. I'll go through the ins and outs of just the basics, and we'll work through an example together, analyzing some data. So in the end, we'll end up with some fancy report that hopefully you'll find is relatable to your work as well. So just a little, set the stage here. What are we going to do today? We will learn the basics of MATLAB and how we can use it for data analysis, just like the title says. The bulk of it, we kind of dubbed this as a workshop, but it's more of a walkthrough. Hopefully I will leave enough time for you to also follow along on nanoHUB or on your desktop if you do have an installation. And after we do the walkthrough, if we do have some time left over, we'll share some resources that will help you learn a little bit more about MATLAB. If we don't have enough time, don't worry. I want to prioritize the example first, and then I can send to all of you the resources, which are incidentally are linked from the nanoHUB tool page. All right. Since Ali introduced me, I'll just kind of skip that. All right. First things first, just overview of what we're going to discuss today. What is MATLAB? I do want to start off with the data analysis workflow. How do we get stuff done in general, MATLAB or not? And then followed by the fun part, the demonstration. I will introduce you to the MATLAB environment. It looks like most of you already know it, so hopefully it'll be just a review. And then the process of doing data analysis. So you access data. You would explore it, you might plot it, and then some other things that are, a little bit more mundane, but just as important, such as creating documentation and automating the process. And again, if we have time left over, we'll go over some resources that will help you in learning about MATLAB a little bit further. Okay, now to kind of set the stage with the demo, I like to play pretend. So I was in the auto industry, so I brought in kind of an auto example here. Let's say you're part of a research group and you asked your staff for the report on fuel economy trends of motor vehicles in 2007. and you receive the following report. You get this nice little PDF. It has a beautiful title, explanation of the data, table of contents, which are hyperlinked, some instructions, or rather directions on what the researchers did in terms of bringing in the data. You've got some code here, details about the data that we're going to be looking at, more details, and some more interesting things such as plots of the data. Also additional visualizations such as maybe the distributions of the data, as well as some statistical analysis as well. So the steps that we're going to follow today is a small subset of what we're seeing today. And after today, you too will also be able to create a beautiful report like this that you can hand to your supervisors and colleagues. All right. So MATLAB. Again, I'll be a little short here since most of you already know MATLAB, that it's a engineering tool designed for engineers and scientists. There are a lot of toolboxes, a lot of new toolboxes, in fact. Like, for example, deep learning didn't exist a couple of years ago. We also have a host of robotics toolboxes as well. But the usual, machine learning's been around for a while, computer vision, image processing. Pretty much anything in engineering, there's probably going to be a toolbox for it. The strength of MATLAB is certainly the fact that you can interact with your data and your engineering tasks a little bit easier. So we have interactive apps that can automatically generate programs, which we will demonstrate today. If you have very large data sets that run very slowly, you can scale your MATLAB programs to clusters, GPUs, and computing clouds to speed up your computations. You can do direct deployment to enterprise production enterprise applications. And last but not least, you can take your code and convert it to embeddable C and CUDA code, so you can put it on an embedded controller or the like. And hopefully we all know that MATLAB, there are many reasons to use it. It's powerful, and this is the big one. It's easy to learn, code, and scale. I'm a mechanical engineer. I'm not a programmer. MATLAB was very easy for me to get into and extend and actually use in control systems. Professionally built, we've been around for over 30 years, and we've got a huge team of coders, but also people who make sure that we have a very high quality software. I mentioned about the toolboxes. Anything in engineering, you're probably going to have a toolbox for it. And did I mention apps, interactive apps that will help you through your engineering tasks as easily and quickly as possible. All right, so enough about MATLAB. Let's take a step back. Now, we want to analyze data. Let's think about how we actually do this. And from our experience, we've seen that people, when they analyze data and you break down what they do, it comes down to three different parts. One is you access the data. Maybe your data is in a bunch of files. Maybe you get it from third-party software. Heck, you might even have some hardware hooked up to your PC that you're getting some data. The point of this is you want to go through this as quickly as possible. It's not really what I would call value added. And you want to move on as quickly as possible to the next part, which is exploring and discovering. Of course, data analysis and modeling is going to be the big part of your tasks. Maybe you might be developing an algorithm based on the data. Or maybe you might be developing an application that will make it easier to kind of cruise through your data or possibly help you with the algorithm development. And when that's done, you'll have a wonderful wonderful sense of accomplishment. But you're not done, because data and your results are completely useless unless you can share it. And we all, we don't like writing reports, but that is the main way to communicate your results to your colleagues and managers. You might take your algorithm, you might give it to another design department for use in their, let's say, control system. Or you might take that application that you use for yourself and then deploy it on a production server so that you can sort of, share that application with as many people as possible. So we've got 3 steps: access, explore, and discover, share. It's not a linear process. You might grab data, explore it. You might find that the data is bad. You have to go back and access it again. That's why the double arrows. And also, you're not going to be doing this just once. This is pretty obvious, and you might have thousands, tens of thousands of data sets. So automating this process is equally as important to actually really get your job done. And we'll be demonstrating examples of this during the demonstration today. All right. Okay, enough PowerPoint, time for MATLAB. Here we have the nanoHUB homepage that we all know and love. I'm already logged in, and okay, how do I get to MATLAB from nanoHUB? Well, there's a couple of different ways. MATLAB is actually one of the tools as part of the resources, but nanoHUB has tons of tools. It's so it might be a little bit difficult to get to first. What I tend to tell people to do is go into search, type in MATLAB. On the left-hand side, filter down to resources, and then filter by tools. And it should be the first one that pops up here. And it's we do have one version of MATLAB. It's about a year old right now. That's what the 2021A is for. So we'll go ahead and click on that link. Okay. So we got a question here, how is MATLAB different from Python? So they're very similar. They're both scripting languages and environments. MATLAB goes, there's a couple of key differences. First of all, MATLAB, when the toolboxes are designed to be integrated as part of MATLAB. Also, the other key difference is that, and I'm going to explain this later, is that MATLAB under the hood handles numbers as matrices, and there's a couple of different benefits to this. Not only how to sort of express calculations, but also there's a performance gain to be had. There are many other differences with Python. I'd be happy to maybe get back to you later if you have something specific that you'd like for me to highlight. I'd also like to mention that MATLAB actually works with Python. And if you are interested, I can provide information on how to integrate MATLAB with Python. Okay, so back to the MATLAB tool page here. We've got just a quick explanation of MATLAB, examples of how you would want to use MATLAB in different disciplines. And also, for those of you who are relatively new, or maybe even you've used MATLAB for a while, we have these free self-paced online courses called on-ramps that you can access. So I would highly encourage you to take advantage of that. But today, we're going to go ahead and jump into the tool. So I'm just going to go ahead and launch it. And of course, just like every other nanoHUB tool, it is running on a remote server, so you might have a little bit of a delay. That's what this message is telling you, that it might take up to a minute until you can interact with it. In my case, it came up pretty quickly. And the trick that I do is I want as much real estate as possible. I usually just try to expand my browser, and then in the lower right-hand corner, you can resize your window. So this should make it a little bit easier to maximize your screen real estate. And here we go. We have MATLAB up and running. There's a couple of different ways to interact with MATLAB. There's quite a few, so I'm not going to get to all of them. I'll kind of bring them up as I go along. One of the more primary or ways to interact with MATLAB is down here in this command window. I just mentioned a couple of seconds ago that MATLAB is quite unique in the scripting world in that it handles everything as a matrix. Even a scalar like 1 or 5 or pi is a 1-by-1 matrix. I'll give you folks just a second to pop up MATLAB in nanoHUB or launch MATLAB on your PC. And let's just do a really trivial example together. I'm going to go ahead and create a matrix. Let's start off with a vector. I'm going to assign a vector to a variable called a. And how do I do that? Well, vectors, or I should say matrices, are built using square brackets. So in this case, let's say just something simple: 1, 2, 3, 4, 5. We'll close the square brackets. Hopefully you're able to follow along, and here we go. We have our nice little 1-by-5 vector. And if you notice here, there's a pane here called the workspace pane. This is kind of like the memory area for MATLAB. And it keeps track of any variables that you create from the command window. Okay. And all right, so we're dealing with vectors and matrices, which tells me, maybe I can do some matrix operations. Let's take the transpose of A. A transpose, which is A single quote. And here we go. Now we have a column vector as opposed to a row vector. And lo and behold, we have B over in the workspace pane. Okay, that's all fine and dandy, but I want to do operations. Okay, great. Now we're getting somewhere. Why don't we do something like maybe do some matrix multiplication? So we'll do A times B, and we get a scalar, which, if you remember back in linear algebra, because of the dimensions, you end up with a scalar in this case. If you do the reverse, B times A, now you'll get a matrix like this. Okay, all right. Now I understand that MATLAB, I can, stands for Matrix Laboratory. I can do matrix math. Wonderful. So, why is this good for me? Well, in my case, and in today's case, since we're talking about data analysis, let's say this is your data, your matrix. It's probably not going to be just a 5-by-5 matrix. It's going to be thousands, tens of thousands big. To process a matrix of that size in traditional programming languages, let's say, take Python, for example, or even C or C++, I would have to program a for loop. In fact, I need 2 for loops, one to work on the row dimension and the other to work on the column dimension. And this is the simple but really awesome part about using MATLAB, is that I can take a matrix, dump it into a function in its entirety, and it'll automatically work on each element. So if I wanted to take the sign of the vector for the matrix, I just type in sign of D here. And boom, here we go. So again, trivial example, but imagine you had a really large data set. Being able to do this, from my experience, it makes things a lot simpler from a programming perspective. And, there's also, from a computation perspective, doing this in MATLAB is actually a lot more memory and speed efficient as well. We have a lot of optimizations in the background that's suited for computations like this. Okay. So, so we've got, hopefully you've been able to follow along with me. And I'll give you just a second just to kind of catch up and think about it. Okay. By the way, I do have some sort of housekeeping things that I do want to mention about MATLAB running in nanoHUB. Sorry I have to go into these details, but it is a bit important. This session here in nanoHUB is allowing MATLAB just to go to MathWorks.com. For better or for worse, our documentation relies on other websites as well. When you call up the help, clicking on this button, you might not get the help screen. It might you might get a blank screen. So what I would suggest that everybody does when they start their MATLAB session, I think it will, I think it persists as well. If you go to, I think it's Home, you go to the Home tab, and you go to Preferences, which is over here. You have a whole bunch of settings, don't get scared, but if you go into MATLAB, there's a section for help. Make sure that your documentation location is pointed to install locally. All the documentation is loaded on the server, so you should be able to access it. If you click on this, it probably won't work, so leave it installed locally. Press OK, and then you should be set. You should be able to click this friendly little help button. Our help browser comes out, and you should be able to see all of our documentation and wonderful examples that we have to use MATLAB. Okay. What else is there? I talked about the screen resolution. Okay. Now you might be wondering, oh, what's this thing just above the command window? Well, we have prepared for all nanoHUB users 2 examples, especially, I was hoping it will be useful for people who are just getting into using MATLAB. MATLAB is a scripting language, and you can, like the name suggests, you can write scripts. There are 2 different types of script formats, and which are automatically loaded when you start MATLAB in nanoHUB. The first type is a .m file, or just simply a MATLAB file. It's just a simple text file. It's only text. You can put comments in here, but all it is it's the text here is run. If you run this script, it's as if you're typing these things in the command window. And to run the script, if you go to the top and you go to the editor, and if you run it out of the box, it's going to tell you this. It's going to tell you change the folder. And that's because MATLAB has it knows where you are. It keeps, there's a semblance of a working folder. And up here, this is what my current folder is. MATLAB is complaining because this script is located in a different folder somewhere in here. And by the way, it's a good time to show you this current folder pane. This is where I can navigate to, let's say right now it's in the template, so I'm going to double click on that, and this is where the scripts actually live. So let me go back and go ahead and run that. I'm not going to go into this example. You can check it out yourself, but you'll notice that a couple of trivial calculations, you get a nice little plot here. We'll do one as well. The second type, which we're actually going to be using in our example, is a live script. You'll notice that it's a lot more user-friendly in terms of the formatting. You can have bolded sections, a lot more rich text. You can put in hyperlinks. By the way, the hyperlinks probably will not work, just to let you know. It will work if you have a PC version of MATLAB. You've got a table of contents. And of course, because it's a scripting language, you have the code. And to run this script, it's just like the other one. Now it says live editor instead of editor. If I go ahead and click on run, it'll go through each of the blocks of code located in the script, and it spits out the output actually on the within the live script itself, very much like Jupyter Notebooks if you work with that. You have the option to have the output on the right hand side. You can put it on the bottom here, or you might be able to just show just the output as well by clicking on the buttons over here on the right. Okay. All right, so enough about the interface. Hopefully you'll get a little bit more familiar with it as we work with our little example. I'm going to go ahead and close the editor. And, well, before we go on to the examples, you know, let's go back and think about our workflow here. When we're dealing with data analysis, we need to import the data into our environment, wherever it is. And, traditionally you would open the data, right? And then you'd have to take a look at it. And then you might not need all the data. So my file might have, say, 10,000 parameters and I only need 3 of them. I have to decide which ones to bring in. Your data might also be corrupt in some of the lines. Maybe you're missing some of the cells in the data and you have to filter it out. Well, in traditional scripting languages, it's perfectly doable, but I'd have to write a script to bring in the data. I'd have to write a script to take a subset of my data. I'd have to write a script to filter out the bad data. And when all is said and done, it's a lot of scripting, right? Well, MATLAB, especially now, offers you a much easier way to import the data. And let's go ahead and try the example ourselves. So let's access the example. It should be loaded on your nanoHUB, the working directory for MATLAB. This is what you should see when you start up MATLAB in nanoHUB. You should see templates and workshops. Of course, we're going to go into workshops. And we have Intro to MATLAB workshop. And by the way, a little plug here. Next week, we're going to have a machine learning workshop delivered by Gabby. And let's go to the short demo. Okay. So just got a quick question on how do you manage data with timestamps. Let's see, example, plot how a parameter changes over time. So for example, there's a couple of ways to do that. One static way of showing changes of data over time. You can have a 3D plot where one of the dimensions is time. The other way is you can generate plots that are animated, so that you can let's say it's a sine wave that changes, the frequency changes over time. You can create an animation that actually shows the sine wave changing of frequency. I'm sure there are other ways to show data as well. Like, for example, one of the customers asked me, "Oh, I want to track animals going through the Yukon. Can I do that?" And the answer is yes. And that relies on animation or stream particle animations that we have. So hopefully that answered your question, Carolina. Okay. Hopefully all of you are in the directory where the demo is. So under workshops, Intro to MATLAB workshop, short demo. Let's go ahead and open up this short demo. Well, yeah, short demo.mlx. Okay, we'll kind of let this sit aside. We'll go back to this later. But first, what I want to do is I want to manually pull in the data that we're going to be dealing with. So to do that, and I apologize, I'm going to need to speed up a little bit. So we'll go to the Home tab. Let's click on Import Data. And automatically, MATLAB detected the file format that it can import. In this case, it's an Excel file. Let's select it and open it, and let's see what happens. We'll give it a second. The GUI popped up immediately, and it's loading the data. It's a small data set, so it's pretty quick. And here we go. Here's the data. Interface should look familiar, but a couple of different things. Here's the range that you want to put in. You can specify if you don't want just a subset, you can put it here. In this particular case, my variable names are row 1, and it automatically detected that. I didn't have to do anything special. The output type is, there's several different output type formats. I'm not going to get into it too much, but table kind of brings, has some additional metadata that makes it easier to process after the fact. Today, let's go, if you're walking along through this with me, let's select column vectors. Because today, what we're going to do is we're going to find a relationship between a vehicle's horsepower or power with the fuel economy, which is miles per gallon. And we've got here, if we go to column F, I'm going to go ahead and select that, just like you would, let's say, in Excel. And I'm going to control click on MPG, because that's the second column of data that I want to pull in. I don't care about all this other stuff. And again, I don't have to write a script to do this. I just kind of clicked on stuff and selected what I want. This example doesn't have any bad data, but if you did, this is where you would actually control that. If you have any unimportable cells, some sort of corrupt data in one of the cells, you can either replace those cells with a value of your choice. In this case, it's not a number. Or what I tend to do is I would exclude the entire row with that unimportable cell. Okay, here, let's see. Yep, and you can import using code. That's a great question, and we'll actually see a little bit of a trick in a minute. With the GUI, if I click on this import selection, it tells me, hey, okay, I've selected your rated horsepower miles per gallon. Let's check this out. Let's go back. Keep the do not close the import window. Click on let's go back to MATLAB. And now you'll notice that in our workspace pane, I've got my miles per gallon and rated horsepower. It looks like I've got this other data that I have left over. So actually, I want to start from scratch and actually answer the question about bringing in data with code. If I want to clear my workspace, if you go to the Home tab, there's a Clear Workspace button, and that will blow everything away. But before I did that, I showed that with a click of a button, I can bring in my data into the workspace. Of course, you're not going to be doing this every single time you bring in code. And so what I'm going to do today is, instead of just clicking on this friendly check button, I'm going to generate a script. So if now what that will do is MATLAB's flashing, so it did something. At this point, we can go ahead and close this import window. In our editor, you'll already notice that it created this script to do that. And the core command, by the way, that reads in the data is read table. So hopefully that helps. And as far as there was a question on how big of a size, how big of a data set can I import? There are several different data formats, but we've made some improvements where you can pull in terabytes of data, with chunks at a time. There's a type of data set, I forgot what it was called, I apologize, but we're able to read databases and tables and then chunk them up so that you're not limited to your PC's memory space. So I don't know the exact number, but let's say we have applications running on terabytes of data. So here's our script. Again, if I type these lines in on the command window, I could do exactly the same thing. But of course, the power of writing a script is that you can call it later. So I'm just going to go ahead and we can go ahead and save this by going to the editor window, click on save, and then I would give it a name. I'm just going to just kind of cancel out here, since we've already actually created a script called my data import script that I have pre-prepared. It should pretty much do the same thing. Now, to run the script, I would just type in the name of the script, my data import script. And I've actually done that here in our live script here. And here's the line of code to execute. Now, in live script, you'll notice these. Let me expand this a bit because it's a little bit space constrained. Live scripts have these sections, so it's these blue bars. You can create these sections by going to the Insert tab, section break. I can tell MATLAB to run the code that's in just one section. How do I do that? Well, you have this nice big button that says Run Section. Let's click on that and let's see what happens. It's already processed it. Let me minimize this again. And here we go. We have back again our mile per gallon and rated horsepower data. So there we have it. We just imported data, actually created this multi-line script in a matter of minutes. Okay. And specifying the data types of the import. Let's see. I think there was a way. Well, you could probably write a script to convert data types of the data that's imported. As far as the inherent capability of the import data, I didn't think there was a way. Did not think there was a way to do that. I got text options. Yeah, you would have to import it. You would have to import the data, and then you would need to write a script to sort of convert all the data types. There are certain things that are kind of automatic, like for example, numbers will be recognized as data type double for the most part, and the other stuff will be text. So, we had a question on what toolboxes are available. What MATLAB toolboxes are available on nanoHUB? And quite a few. You can actually find out exactly what is included by going to the command window and typing in VER for version. And, it won't even fit on one screen, let's put it that way. So it includes pretty much all the toolboxes. Now, note that this is running on a Linux server. So there might be some issues running certain toolboxes, especially those that rely on hardware or GPUs. But for the most part, all the toolboxes are available, including Simulink, which is our graphical modeling tool. You can use that as well. Okay. Yeah, managing data with timestamps. I had a question on that earlier. Yeah, I think I answered that earlier, but again, there's two different ways. You can plot a 3D graph with time as one of the dimensions, and the other is you can actually create an animation based on the data. So that's probably going to get a little bit involved beyond our scope today. So if you are interested, whoever asked that, please feel free to get back to me on that. I'll hopefully we'll be able to provide our contact information. Or even better yet, if you go to nanoHUB, if you join the MATLAB group, I believe you can also post questions. Very well. Okay, so back to the script now. Now that we've imported, when you import the data, I always like to check to see how it is. Namely, a lot of the times the data that you're bringing, you can view it visually, and you can tell whether it's quote unquote good or not. To visualize it, there are various ways to plot the data. And again, normally you would have to write a script to plot the data. You might have to pull in a library to plot it. But in MATLAB, everything's all internalized. And in fact, you don't even need to type anything. If I go to plots, there's a plot tab here. You have here a host of different types of plots depending on the data that you select. Looks like I had rated horsepower select here, but today I want to do rated horsepower and miles per gallon in that order. If you have it reversed, you can click on this to flip it. So I just press Control-click to select the two. And here we go. Let me do the most basic one. Let's just do a plot. Well, it's kind of, I kind of see a trend here, but it looks like a rat's nest. I don't like it. Let me go ahead and close that. And in this particular case, a scatter plot might work better, which is great. Looks a little bare. You know, I might want some text such as a title, you know, say horsepower versus MPG. You know, maybe I might want, you know, an X label. This is where my horsepower is, and a Y label. You go to Insert. Maybe I might want to change the properties of my. I can click on the data points as well to see what the numbers are. Alternately, what I can do is I can click on this little cursor thing here, and then if I double click on the you know, the axis window, it pops up this property inspector, and through this property inspector you can change any property of the plot itself. So just to let you know, it's there. And of course, if I have 10,000 sets of data, I don't want to be doing this every single time. So just like in our import example, let's go ahead and create a script. In this case, I'm going to click on File, Generate Code over here. And what that's going to do is, well, no surprise, it creates a script that generates that exact figure. This is a little bit different from the last script that we saw. We call this a function, and a function is a script where you can, of course, specify the function name, but also very specific inputs and outputs. And the reason why you would use a function over a script is because a function is a lot easier to reuse. So if I wrote a script that's not a function, I might have to rewrite it for a different data set. If I use a function, I just tell it, create my figure for X1, Y1. In this case, it's, you know, rated horsepower, miles per gallon. Again, this is in the editor, so if I want to save it, just go to Editor, Save, and create your file here. Again, I've already pre-prepared a script here to do that called my create figure, and I have changed some stuff. You can change the stuff after you generate it, and to run it, you know, just like in the import example, you just run it here. So we're back in our live script, and let me go ahead and run this section. In fact, I got this other stuff that I put in here. I should have deleted it. So let me go ahead and run the section, and you'll notice that here's our plot again. Another nice little thing is if I say want to zoom in on a portion, there are controls here to do that. And if I like this view and I want to use it, reuse it, you'll notice that it generates the code that actually does that action. And I can go ahead and press Update Code, and it appears right below where I called the function, which is kind of handy. Again, it's really interactive. You don't have to rewrite code. All right, let's see. So, okay, let me move on. Got about 10 minutes left. So finally, we're kind of at our, really the main thing that we wanted to do. So all we've done is we've imported the data with a few mouse clicks. We've, you know, checked out our data, again, with a few mouse clicks to plot the data. We've generated scripts to do both things so that we can repeat it over and over and over again. But now is the fun part. And the type of analysis that we're going to do is we're going to take our data, fit a curve to it, and our, you know, quote unquote model is just going to be an equation, a curve based on the data that we pull in. Okay, Traditionally, if I were to do this in another scripting language, I probably would have to pull in another math library. I would perform my statistical analysis on my data using a script. Once I have my equation representing the curve, I would have to translate that to some other script, and then that's it. But again, that is a lot of scripting. It's a lot of iterative. It's an iterative process because the curve fit that you try out in the beginning might not work, so you might have to repeat that process over and over and over again, which might mean that you might have to edit your script over and over and over again, or possibly even sweep the curve parameters. MATLAB provides you with something that's a little bit easier, and it kind of centers around what we call apps. You go up to the toolbar and you go to the apps tab over here, and most everybody should see exactly the same thing here. All these apps are dependent on what toolboxes you have installed, and on nanoHUB, everybody should have the same toolboxes installed. Your PC might have a different set. These apps are, like the name suggests, they're applications, which makes certain operations a lot quicker, like curve fitting, like we're talking about. There's other things like control system design. There's neural net stuff. And today, what we're going to do is we're going to select the curve fitting app. If you can't find it somewhere, you can always type in curve fitting or curve and narrow it down. Let's go ahead and click on that. And yeah, here we go. Here's the curve fitting app. Let's go to the basics. Here's on the upper left-hand side, we have where you would specify what data do you want to fit to. Well, like I mentioned, in this case, our independent variable we want as the rated horsepower. For the Y data, the dependent variable, we want to use miles per gallon. And you notice here already, without me doing anything else, it plotted the data, and it kind of did a default fit of just a linear fit. Chances are it's probably not going to be the right fit, but that's okay. And now at this point, really, especially if I don't know what type of curve to fit my data to, I can go to this pane here and select the type of fit. So let's keep it as polynomial. Maybe I want to increase the degrees of the polynomial. Let's see what that looks like. In a flash, it updated the curve fit. I can kind of eyeball things. On the left-hand side, don't forget we're engineers and scientists. We deal with numbers. It looks good, just doesn't quite cut it. So in curve fitting world, we're talking about statistical operations. On the left-hand side, we have our coefficients, but you also have statistics on how good the fit is, using statistics speak. So I tend to use R-square quite a bit. The higher, the better. Right now, it's at 0.288. And this particular example, I already know that this data should theoretically fit to a power curve. So let's go ahead and do that together. I'm going to go ahead and select power. And already we have an R-squared that's a little bit higher. I'm going to bump up the number of terms to 2. So here's our look. It looks a lot better. But again, let's look at the numbers. We've got our coefficients, and we have an R-squared just above 0.3. So yeah, what happens when you have multiple X or Y variables? That's a good question. Yeah, this does handles up to three dimensions. For higher variables, multi-dimension variables, there are other ways to create models. Again, curve fitting is just a means to end up with a model. If you wanted a model that handles multiple dimensions, this is actually a great time to sign up for our machine learning webinar next week. and you can actually learn about creating a model that can handle those higher dimensions. Okay. Okay, so we got our fit. I'm happy with it. What do I do now? Well, I don't want to, I don't want to write on my pad of paper the parameters here. I want to be able to do this analysis on my thousands of data sets. So what I'm going to do, you can probably already guess, we're going to generate some code straight out of this tool. If I go click on File, Generate Code, looks like it already did its thing, so I'll go ahead and close this. You can save this curve fitting session for later if you want it. I'm just going to click on No. And lo and behold, in my editor, I have my function that does that fitting based on the inputs that I specify. So I can reuse this for multiple data sets. So great. I'm not going to get into the details of this, but again, if you wanted to modify it, this is a script just like any other. You can modify it to your heart's content. For now, I'm just going to kind of close it, and I'm just going to go ahead and actually run a fit one that I prepared that you also have as well. And I will call it from our short demo live script here. I'll go to the section of code. This is where I use it. We have our inputs. In horsepower, let me go ahead and run the section. It's telling me that it's removing some nan and inf from data, so maybe I did not do a good job in cleaning it up. So that's a problem with the import process. But most importantly, I get two outputs here. One is the fit result. This is the model, so to speak. It includes the coefficients and it has some other metadata. And you'll notice that if I highlighted the variable, and this is the case with any variable that you highlight in a script, it will try to sort of find it and then display the information about it. And the second output is the statistical information about the goodness of fit, therefore, GOF. And there's our R-squared of 0.3096. Another nice bonus of using this function that was automatically generated is that it'll give you a plot of the data and the curve fit. Okay, down here, you got the goodness of fit result and the goodness of fit. Okay, the last step that I'd like to sort of introduce you to is, so we have our model. We need to do something to it. What I like to do is actually put it through its paces. And normally, in traditional programming languages, I would take, the script or the model that I created and then run it through another script. I want something a little bit more interactive. And this is where one of the values of having a live script, and let me just, delete some stuff here. Just kind of got ahead of myself here. Okay. This is an example of a control in live scripts. You'll notice that here's my fit result. This is that model, and I'm passing in a value. And I can actually control the value using the using the slider. Oh, and let's see. Gabby, I'm just going to paste it in our Teams chat. So, okay. So, how do I do this? Well, let's do one together. You can add this sort of code block by going to the live editor. Click on code, and then you can type in your code. Predicted, and I just typed in PRE, and MATLAB already is thinking ahead of me and saying, hey, do you want to use this predicted miles per gallon? Why, yes, MATLAB, I do want to use it. So I'm going to go ahead and click on it. And that's going to be equal to my fit result. I just typed in fit and automatically said, hey, do you want to use one of these? Yep, yeah, absolutely, MATLAB. I want to use my fit result. And normally, if I were just running like a plain vanilla script, I would put in a number, like 100. And then if I run the section, it'll give me an answer. In this case, because I want a fancy control, I'd go here, go to control, and then I can select different types of controls here, sliders, drop-downs, whatnot. Today, we'll add a numeric slider. A little submenu pops up. I can control the parameters of the slider. I want a min of 0. Maybe I want max of 500 and steps of 50. And it also controls what happens if I change the slider. Do I want to run that section when the value is changing or the value has changed? And when the value is changed, do I run just the current section or maybe all the sections, maybe the whole script? Today, I'm just going to do current section. Let's click away from it. And now, here we have my, my slider. Wonderful. This is, of course, not only good for you, but the nice thing about these live scripts is, communication. It's that sharing part that you saw at the end of the process. You're going to want to give this to your colleagues. You're going to want them to sort of follow along what you did, which hopefully, you've explained what you did in prose, and also repeat the same results that you got. And also sort of give them a chance to sort of expand on what you did through interactive controls like this. Okay, let's see, that pretty much covers the basic things that I wanted to go over today. Any questions at this point? And then, and just one last thing, by the way. The other part about sharing, some people don't have MATLAB. You might need to provide a report. You can go to the live script, save it as, and you have the option to save it to a PDF, Word document, or an HTML file. Here's the example of an HTML file. Looks almost like the live script, and hopefully this makes it a lot easier to share your results with your colleagues. Okay.
Yeah, perfect. Well, let's thank again for a terrific presentation, and not only giving the presentation, but this is, I think, the best example I've seen of multitasking and answering the questions while you're giving the presentation itself. So that was terrific. And all this Q&A will be moved to the nanoHUB group that's called MATLAB group. There's a forum there, and you can continue to ask questions, and the community, Gen, Gabi, can answer, and we can have a place for discussion. I really want to emphasize what Gen was saying towards the end about the ability to document with nice text and graph and live code. That's, I think, very powerful. If you're a professor, you can have a full hands-on live lesson plan and share it with your students and with your colleagues. And nanoHUB is very happy to be the place for you to share those resources. So be in touch or just log in nanoHUB and contribute resources. The site is open and ready for people to share material in it. So thank you again very much.
Yep. Thank you, Ali. Thank you, everybody.
Terrific presentation.